Written. Today I want us to discuss about what is current. What is current actually? I want us to discuss about what is current. Right. So guys, you must know what is current, right? Uh, Current is given by it is which is I denoted by I, which is current is the amount of charge or it's a rate of is like this is the charge divided by change in time, right? So it's a electrical current is the rate of flow of charge actually. It's just the amount of charge flowing per seconds in the electrical conduct. So it's just I can say this is simply what is the rate of flow of charge, right? This is what it's a current, right? Is the rate of flow of charge that is current, whereby we know that uh whereby we know this I is a charge is measured in coulombs, this Q is charge measured in coulombs, time is always measured in seconds. So that means I actual is equal to is coulomb per seconds, amount of charge that flowing through a certain point per seconds, amount of charge per seconds. So yeah, this is measured in coulombs per seconds. That means when you see coulombs per seconds is the same as amp, whereby amp is ampere. It's the one and the same thing there, right? So yeah, so therefore I is equals to Q over change in T, which is coulombs per seconds actually, divided by seconds, like this. That is your current. So for example, let's say now we are given an electrical circuit. What you must know, let's say you're given a positive terminal, it's always long. Let me just say positive terminal, then here a negative terminal must, we've given this circuit like this. So here we have a resistance, right? You have a resistor here. This is our, let's say here we have a voltage 20 volts. Then you must know the conventional current will always flow from positive terminal. You see this horizontal line, the big one. This one is a positive terminal. We call that the positive terminal. So our conventional current will always flow from positive terminal to the negative terminal. So that means here will be flow. As you can see, this will be the direction of what? Of a current. Let's say 7 amperes flowing. Will flow like this from the positive, and then we'll pass here to resistor R, and then we'll go and move and move and move and return back to the, you see. So then the electrons will flow in the opposite direction. This will be a flow of electrons if you are given this, right? So you must know that as you can see, I like to treat the current as watt. Let's say now there is 12, there is 7, you said 7 amps, let's say it's a 7 liter of water. Then this is my tap. Then I open this tap. The 7 liters of water will move and move and move and move and move and move. Also will pass away at the resistor R and move like that and return back. So in other words, as you can see, if I can take the same circuit, right, then let me say here, let me put that resistor here. I can call it resistor 1. Then I take another resistor here, I place it here. Then I say resistor 2. Then you see, like this. So let me say this 7 ampere of current is flowing, will flow from positive terminal, will always flow from positive terminal towards negative terminal. Then the electrons will flow in this direction. What I'm trying to say, what will be the current that is flowing to resistor 1? You can see I say it is like what if I open 7 liters of water. Let me say 7 liters will pass here at R1. Also the 7 liters will go and pass where at R2 and return back. So resistor 1, at the resistor 1, what will be a current here at resistor 1? What will be the current that will experience? This resistor will experience I can say a current of, will read the current of what, of 7 amps. 7 amps. Also that 7 amps will pass, and also the at resistor, let me say resistor 2. So here this will read 7 amps also. So what I'm trying to say, you must know that when resistance re, resistor when are placed in series, right? Their resistance resistor when are placed in series, they have equal uh equal current, which is these are resistance in series, right? If they are placed in series, they will have a equal current. As long as the resistors are placed in series, they will have a equal current. However, if I have parallel resistor, right? If I have parallel resistor, let's say I place the resistor in parallel. Let's say I decide to place them in parallel, like that, like this. Let me say R1 here for argument's sake. Let me say here R2, right? I place them in parallel. So by the way, let me say here we still have the 7 amps that is flowing, will flow from positive terminal towards a negative terminal. As you can see, the 7 amps flows, when it reaches to this point, will start splits. Imagine you have a tap. I would like to make example with a tap. You have a tap there, or let me say you have a pipe, you have a tap actual. Let's say you have a tap there, right? You put a hose pipe. If you apply the hose pipe, the water, if it's like this, let's say now this pipe it becomes like this. This is still pipe, is flowing like this, other pipe is flowing like this. If I open, let's say now I turn on this pipe. If I turn on, the water will flow. You see the water will flow there. Here is the water that is flowing, will flow and flow and flow. You see some of the water will go down like this, some of the water will pass like that. This is simply like, it's like a current that you see. This is like simply like a current. You see this water will split at this point, at this T junction. So also you have a T junction. So this current, there will be a current that will flow like this, and when it reaches to that point here, at this point, another one will flow through resistor 1. The other one will flow through resistor what, like that branch. And as it flows, this current will meet here. As you can see, then this current will continue and return back. That means will meet here, will split here, and also meet here and return back. As you can see there. So it just splits. So it's like this. Let me draw this pipe again. Let me say here we have it. I want to show you how it is. This pipe returns back like this. As you can see, the other one is now is 2 liter of water. For example, this water will split here. Let me say from this branch, from downwards, maybe 1 liter flowed through this direction. The other liter will flow to that direction, the 1 liter. As you can see, this will flow and flow and flow and flow and flow. This water will meet here at this junction. Then it will be a sum off again. When you sum up this water will return back to become what? This water will become 2 liter again, even though it was 1 liter. The same thing, like treat the current as like this example, right? So then you will understand what it is. So as I say, you must understand that the current, the resistor, okay, we are talking about the current, we're not talking about the resistance. It's fine. They were just discussing about the current. So let me say let me do like this. Want you to check something. We have a dot like this. Let's say now 7 amperes current here flowing through this direction. As you can see, let me say here, as it flows here, 3 amps flowing in that direction. What will be the current that is flowing downwards? What will be the current that is flowing downwards? So you must know, initially we had 7, right? The original one was 7. When KTC split this, that means the other one that will split, the current that will flow down will be 4 amps, as you understand. From this injection, they will just split. You understand? Then let me say again, it's contain again. Let's say it contains and contains, and then it is, then let me construct like this. As you can see, these 3 will flow, these 3 amperes will flow, these 3 amperes will flow like that. Still 3 amperes there will flow, as you can check. And also this 4 will flow like this. You see, when they meet there, this point, what will be the current at this point? Just at this point there. So the current there at that point, the current at this point here, at this point there, you must know that will be what? The sum up. Remember, there will be 3 amps that is flowing. This 4 and 3 will meet here. That means we'll have what? 7. Then we'll continue and goes like that. If you can know it like this, it will be good. So in other words, that means for review, or let me say, dealing with series resistor, when your resistor in series, you must know that the current is the same. Let me just say the current is the same as you have seen there, but when the resistor plays parallel, you have seen that the current will differ. So yeah, this is what you're supposed to know. Will differ. That is what you're supposed to know. Will differ. So, and then do not confuse a current and the voltage. Remember, it's a vice versa. If you are given a voltage, let's say in series again, in series, but let us now talk about the voltage. In series, the voltage won't be the same. Voltage drop will the voltage won't be the same. The voltage will differ, won't be the same. But however, when the resistors are placed in parallel, the voltage will be the same. So do not confuse the two. You see, if we're talking about the current is the same on the resist. However, it is a reverse, it is a vice versa. But when the series are placed in, when the resistor placed in series, when we are considering a voltage, will diff. You see, will be vice versa. It's just a vice versa thing, or it's a vice versa. So what you're supposed to know is this thing, this stuff. If you know this stuff, then you're good to go. You can apply your stuff then. So as you can see, are you aware here? Are you aware the equation that we can use to find this current here? 4. How did we get this 4? Let's say it split is, we can say current, the one here, the first one, I can say this I1 or I total, then I can say this is I2, will be I1 here, which is total, or Y total will be equal to I1 plus I2. Did you see that? Remember, we have started by 7, so you can simply say 7, it's equal to, we call this I1, we don't know I1, plus what about I2 is 3, then we want I1, you apply your math, I1, there, apply I1, that means I1 will be equal to, you take to that side, will change sign, will be 7 minus 3, I1 will be equals to watt, therefore watt amps. So let us try another problem. Let's say now we are given want us to check here. I have 14. I have 14, the current 14 amperes flow in this direction, 14 amperes flowing in this direction. Let me say here I have the current in this branch. In that branch I will have, let me say, I will call it I1. Let me call it this I total. For argument's sake, you can say IT, for example. Then I2 there, let me say here we have 4. Then here I2, I will call it I2, let me say it is 3. Let me say it is 7 amperes that will be flowing like this at this branch. What about, let me say this branch, let me call it I, will be I3. So what will be the current flowing at that branch that I've colored it by yellow? So you must know that since we have a total, it split it here. So you can say I total, we know we have started by 14. Then we can say I1 plus I2 plus I3. We want, what do we want? I want I3. We have started with 14 amperes. I1 it's 4, right? Then plus I2 is 7 here. You can say 7. What about I3? Then you use your math, will be 14. Then there you know that 40, we will say 7 plus 4, which is it is what, that is 11 plus I3. What will be I3? You take that to the other side, will be 14 minus 11 I3. Then you do your maths. I3 will simply equal to what, you can say 14 minus 11, right? Then you'll have 3 amps. So this is how you can get it there, you see. Then that means here we have 3 amps. So we have found all of this current that is flowing at each branch. So yeah guys, this is what it is guys. So if you have found my video helpful guys, please do not forget to subscribe. If you found it useful, please subscribe there to my YouTube channel and click that notification button there. You'll see a notification button and click it so that you'll be notified whenever I post a new video. You can share this to your fellow classmates. You can comment and like guys. All the best. Thank you for watching, right? All the best.